we've been mainly looking at two-dimensional shapes. And if you remember, two-dimensional shape would be a square or triangle or something like this, or one of the polygons that has this sort of shape. And it's called two dimensions because the word dimension or dimensional, especially in mathematical terms, is a measure. So this means that there are two measures. So with a square, we can have length and width here, and or length and height, as we sometimes call it. So this bit could be the height, and this bit could be the width, let's say. Now the strange thing is that two-dimensional structures or shapes don't actually exist in reality because it's not possible to have something with just two dimensions in reality. They're used in mathematics quite a lot. But the shape that does exist is three-dimensional. And the three dimensions means that there are three measures. And so in addition to having length and width, there's a third one. And this is called various things. So it could be height and breadth or whatever. So let's look at an example. And we're going to be looking mainly at three-dimensional shapes from now on. And it's especially important for you, James, in stonemasonry because you'll be dealing with three dimensions. And in life, we all deal with three dimensions. So, for instance, we could have drawn this in a two-dimension. So that would be a two-dimensional shape. But in fact, this box exists in a three-dimensional shape. And so there are always three measures, three dimensions. And that the actual word dimension comes from the Latin dimensio, which is to measure. So when we look at a three-dimensional shape, they could exist in various forms, and we're going to cover some of these. So we've seen the cereal box here. How about this sort of triangular shape? So the different parts of a three-dimensional shape are given different names, different terms. That if we just looked at one part of it, say that bit there, and this would be the face. So it would be some sort of a surface, a flat surface in this case. Where two surfaces, two faces meet, it's an edge. So this would be an edge because this is where this part and this part meet. So this part here would be an edge. And this part here would be an edge. You can't see the other bit, but it's where this face and the face around this side actually meet. So these are known as edges. And then there's another term which might be new to you. It's called a vertex. And a vertex is a corner where the edges meet. So this, for instance, is a vertex because this is one edge and it's meeting there. That's another edge and it's meeting there. This is a third edge and it's meeting there. So this would be the vertex. Similarly, this would be the vertex. So this edge meets that edge, meets that edge. I'm sure you've seen this shape around. This is a prism. It's a triangular prism. And it looks very similar to this Toblerone type of chocolate bar. And this shows that if you were to cut this down the middle or somewhere along its length, then this is known as a cross section. So if you take a piece which cuts through the main structure, this is the cross section. And you see that it's a triangle. And not only is it a triangle, but it's the same triangle as this, and the same triangle as that. So a feature with a triangular prism is that wherever you cut it, you produce a cross-section which resembles one of the faces, that one or that one. A very common shape, mainly because the pyramids and things like that in Egypt, is this. So it's a pyramid. And if we look at the base, so this would be the base of it. It has a polygon at its base, and a polygon, if you remember, is any shape that has more than three sides. So here we have a square shape over here, and so this is the base, and then these are the various faces of it. So there's a face and that's a face. Excuse the wobbly drawing. And for this case, for this particular pyramid, all the faces are triangles. And the vertex here, so where all the edges of the faces meet, and so that would be the vertex. Not quite sure if I said that a structure has a number of of these vertex things, and the plural of vertex is vertice. So, vertices. So this last bit then changes to I see. So vertices.